Okay, optimization problems. So, many times in life we're asked to do an optimization problem. Here are some examples. What optimization means is finding the largest or the smallest value. All right, so now when we are doing that, you need to remember, how do we find min and max? They occur when what happens? Yes, when the derivative equals 0 and changes sign. Okay, don't forget it has to change sign. It's not just good enough that it equals 0. You want to check that it changes sign. Okay, so from there, let's look at steps to solving. These ones, go ahead and read them. I'm not going to read them to you, but you want to make sure you are following them. Basically, you write a primary equation and then get that equation down to one variable. So, two numbers add up to 40. Well, let's take two numbers, x plus y equals 40. Find the numbers that maximize their product. We want to maximize their product. So that equation, product equals x times y. We're going to use our secondary equation to go ahead, solve for one variable. We could say y equals 40 minus x and plug that in. So really, that's x times 40 minus x. Okay? So p equals 40x minus x squared. Now we want to maximize that. Do the derivative. So derivative is 40 minus 2x, set it equal to 0. So 40 equals 2x, so x equals 20. Go back over, actually, do a number line and just check that. If we put in 19, where am I here? Okay, so, p prime, 40 minus 2 times 19, that's negative. And if we put in 21, 40 minus 2 times 21, this one was positive, sorry. 40 minus 2 times 21, that one ends up being negative. Increasing to decreasing, yes, we have a max. So the two numbers, 40 minus 20, our two numbers would be 20 and 20. Okay, and that's how you do that one. Let's do another one. Okay, a rectangle has a perimeter of 71 feet. What length and width should it have so that its area is a maximum? What is the maximum area? So we know we want to maximize the area, and area is length times width. Okay, so our secondary equation, perimeter is 2L plus 2W. So we have 71. And we need to solve for one of the variables. So you could do 71 minus 2L divided by 2 equals W. You can split that up. 71 over 2 minus L equals W. That might be easier when you plug it in. So our area, length, times width, which is 71 over 2 minus L. Distribute that. Okay, and now we have to do the derivative. So a prime is 71 over 2 minus 2L. Set it equal to 0. 71 over 2 equals 2L. So L equals 71 over 4. And that's it. That's not it. Sorry. That's L. We need to go back and check 71 over 4. So that is, I don't know, we can put in, let's put in 20 to be above it. 71 over 2 is like, what, 35 and a half. Minus, if we put in 20, that's 40, so that's negative. If we put in, just put in 5, that is positive. So yes, we have a max there. So that's L. We need to find W. 71 over 2 minus 71 over 4 equals W. So if we change that, let's see, 4 times that by 2, 142 minus 71, so 71 over 4 equals W. So So what length and width? Our length is 71 over 4, and we're dealing with feet. Our width is 71 over 4. And so what is the maximum area? You would multiply them together. 71 over 4 times 71 over 4. Get that, and that's your maximum area. Okay? So let's do another one. What's next? All right, here's a good one. A manufacturer wants to design an open box. Open box means there's no top, having a square base and a surface area of 108 square inches. All right, so we have some square box with an open top. It has a square base, so let's call each of those X. And it doesn't say it has the same height, so let's call that Y. Our volume, maximum volume is what we want to maximize. X times Y, so X squared times Y is our maximum volume. So let's see, surface area. This surface area, you have the base, which is X squared, plus this side, which is X times Y, and that's actually all four sides, so plus 4xy equals 108. Think about here what variable it's going to be easiest to solve for. Yes, that would be y. So let's see, you have 4xy equals 108 minus x squared, and then divide by 4x. So you have y equals, let's see, 4 goes into 108 27 times over x minus x over 4, so 1/4 x. All right, so when we plug that in, volume equals x squared times 27 over x minus 1/4 x. Distribute that, you're left with 27x minus 1/4 x cubed. That's the volume. So now to go about finding the maximum, dv dt, I lied, hang on, v prime, it'd be actually dv dx because it's in terms of x, easier to write v prime, 27 minus 3/4 x squared, set that equal to 0, so you have 27 equals 3/4 x squared, multiplied by the reciprocal gives you 36 equals x squared, so x would be plus or minus 6. We know we can't have negative 6 because it's a length, so we have positive 6. Now, when you put that on the number line, plug in 7. Where am I plugging into? Into right here. Let's plug in, I don't know, 8. Let's plug in 8, then we know it goes in. So that's going to be 8 is 64, 16, 48, so that's negative. If you plug in 5, let's plug in 2, that's positive. So increasing, that decreasing, so you have a maximum. So what dimensions? X is 6, so you have a 6, what are we on, inches, by 6 inches, and y is, 27 over 6 minus 1/4 of 6, so that's 3 goes in 9/2 minus 2 goes in 3/2, so 6/2, so 3, 6 by 6 by 3, and there you go. It didn't say to find the maximum value, so you don't have to. All right, this is almost 10 minutes. I'm going to stop this video here, and then I'll start another video. If you want to go ahead and start the homework now, go ahead and try it. If you want to watch more of the problems, then go on to the second video.